Okay, so you asked me for session 1, problem number 3. This is the Louis Vuitton problem. So I'm going to try to do a quick video recording to explain this problem, and hopefully you find value in this. So the problem says that the French luxury brand Louis Vuitton, so I'm going to show here, Louis Vuitton has a production function given by Q equals 100 L by L raised to power 3 by 5 M raised to power 2 by 5. So you have two inputs, one is labor and the other is machine weeks. You can produce the bag in China or France. Regardless of where you produce the bag, the fixed cost is $10,000. What's also given to you is the per unit cost of the two inputs. So in this case, for the machine input M, the per unit cost R is $1,000 per unit. For the labor input, the numbers are different whether you make it in China or whether you make it in France. China, the labor is $300. In France, the labor is $500. So part A of the problem says that what is the total minimum cost of producing 1,000 bags in China. So this is a simple problem of optimal resource allocation. So you know that resources are optimally allocated, and when I say optimal allocation, I mean that the cost to produce a certain output is minimized. So in this case, we are trying to produce 1,000 units of output, so the cost will be lowest when the resources are allocated based on the following relationship, that MPL over MPK is W by R. Okay, now I also told you in session 2 that if you have a Cobb-Douglas form which looks something like this, that if you have Q equals A K power alpha L power beta, then you can directly write MPL over MPK as, look at the numerator, the input is L, so start with the exponent of that input. So in this case, the exponent of the input L is beta, and then denominator same thing, the input is K, so start with the exponent of that input, which is alpha, and then the actual input will be the reverse. So this will be, since the numerator has the exponent of L, the input is K, and so that's the formula. You should have it in your cheat sheet. You can do it in one shot if you wanted. Obviously you can also do it by going the brute force method, where you calculate MPL as the first derivative of the production function with respect to L, and MPK as the first derivative of the production function with respect to K. You can always do that. That always works. But for Cobb-Douglas form, you can write it in one shot. So why am I saying this? Because if I go back to this Cobb-Douglas form here for Louis Vuitton, I should be able to write my MPL or MPK in one shot using this particular formula. So what this will mean is, let me write down the production function. It's 100 L 3/5 M 2/5. So using this approach, I would say MPL over MPK. I'll start with the exponent of L, which is 3 by 5 times M, the other one, divided by 2 by 5 times L. So this should be 3 by 2 M by L. Okay, so that's the first equation. The MPL over MPK is 3 by 2 M by L. Now this, if I am making in China, I know my W is $300 and my R is $1,000. So therefore W by R is 300 by 1,000, that's 3 by 10. Now under optimal resource allocation, 1 and 2 have to be the same. So therefore when I look at 1, it's 3 by 2 M by L should be equal to 3 by 10. 3 by 2 M by L should be equal to 3 by 10, and that gives me L equals 5m. Okay, now what I'm also supposed to say is, well, how many units do I need to make 1000 units of the bag? So Q is 1000. So I go back and then use my Cobb-Douglas equation using this new relationship that I found between the two inputs L and M. My Cobb-Douglas form is Q equals 100 L power 3.5 M power 2.5. So I want to make 1000 units equals 100. Instead of L I put 5M 3/5 and M 2/5. So when I go ahead and solve for M, I hope you know how to solve this equation. You can use a calculator to do it. M comes out to be 3.81 and L is 5 times M, that's 19.04. So what this is saying is that if you want to make 1000 units of Louis Vuitton bags, you need 3.81 units of machine and 19.04 units of labor. Okay, the total cost to produce 1000 bags will be the fixed cost, which is the same regardless of whether you make 1 unit or 1000 units, times the variable cost. So what is the variable cost? The variable cost is number of the cost of labor times number of units of labor plus cost of capital times number of units of capital. You call K, or you can call M here, the same thing. The fixed cost is 10,000 and the variable cost is labor is 300 times 19.04 plus capital is $1,000 times 3.81. So when you solve the whole thing, it turns out to be 19522. So therefore, cost per bag, since you are making 1000 such bags, would be $19.522. Okay, so that's the answer for part A. Okay, so now the second part of the question says, French people are very proud of their croissants and their luxury products. They cannot tolerate that their handbags are labeled made in China. So Louis Vuitton is thinking about abandoning its plant in China and therefore producing all the 1000 bags in France so that it can label each handbag as made in France. Of course, to rationalize making this production, these customers should be willing to pay more for a handbag with the French label. What is the minimum additional amount per handbag that people must be willing to pay for the French label so that Louis Vuitton would be willing to make the production switch? So what it is saying is, well, what is the cost of making all the bags in France instead of making in China? So the cost in France would be somewhat higher because the labor cost in France is higher. So question is how much higher? So that's part B. So let's go back here. Part B, what if the bags were made in France? Okay, so what if the bags were made in France? So in this case, again, optimal resource allocation will tell me that MPL over MPK would be equal to W by R. The only thing that is changing, I mean, the capital cost is the same, it's still $1,000 per unit. The only thing that is changing is W, because W of France is $500 instead of $300 for China. So now that's the only change. MPL over MPK, we already know from this page, is 3 by 2 M by L. The production function is the same, so there is no change. So MPL or MPK, whether you make it in France or in China, is going to be the same. So this is 3 by 2 M by L but W by R will be different now because we are making in France. So this is 500 by 1000. So that's 1 by 2. So in this new world where you are making everything in France, the relationship between L and M is now, so if I solve it, 3 by 2, 1 by 2, so 2 gets cancelled, so L equals 3M. So notice this, the change that has happened. In China, when we were doing it in China, L was 5M. When we are doing it in France, L is 3M. The rest of the process is the same. If I have to make 1000 units, I will compute what the value of L and M is. So Q is 1000. I put this back in my Cobb duplex equation. 100 L power 3 by 5, M power 2 by 5. So that's 100. And instead of L, I put 3M, 3 by 5, and M, 2 by 5. I solve for L and M. M comes out to be 5.17, and L comes out to be 15.52. Okay, so this is obviously different from what you had when you did it in China, where M was 3.18 and L was 19.04. Okay, so you compute, once you have the optimal M and L in France, you calculate the total cost. The total cost is the same. Total cost is the same as before, in the sense you need a fixed cost plus a variable cost. Fixed cost is 10,000. The variable cost is WL plus RK, and you know, in this case W is 500, number of units of labor that you need is 15.52, plus R is 1000, and number of units of capital you need is 5.17. You solve for total cost, it comes out to be 22930. So therefore cost per bag since we're making 1000 bags is 22.930. So when you make it in France, you notice that the cost per bag is 22.930, but on the other hand, when we were making it in China, the cost was 19.5. So the difference is almost $3, 22.9 versus 19.5. So that's the extra cost that the consumer will have to pay if you switch the production from China to France. So hope that helps. Thanks.